Welcome back. All right, already into week 3. So last week we got introduced to stress and the concept of stress and some of Hans Selye's initial experimentations to help us define what stress is. And so this week we're going to dive a little bit deeper about what's known about the biology and chemistry of stress, and we're going to see how that affects our health. So we're going to start with the brain. The brain is a really big and vast place in a small little contained area inside our head. So we won't require that you understand all of the different places or how neurons work. But to begin to understand the process of how stress can make us sick, we do need to know something about the workings of the brain to figure it all out. So all of you are sitting out there in your chairs, not moving a muscle. I mean, maybe you are moving a muscle, but maybe you're not. Maybe you're just sitting there listening to this lecture. But you may have a thought having to do with feeling angry or sad or euphoric or lustful, and suddenly your pancreas secretes a hormone. Your pancreas? How did you manage to even do that with your pancreas? You don't even know where your pancreas is. And then your liver is making an enzyme that wasn't there before. Your spleen is text messaging something to your thymus gland. Blood flow and little capillaries in your ankles has just changed. All from thinking a thought. So we all understand intellectually that the brain can regulate functions throughout the rest of the body. But isn't it still surprising to be reminded of how far-reaching those effects can be? So to understand stress response, we need to know a little bit about the communication lines from the brain to the rest of the body. And that's what we're going to focus on in this lecture. So let's start with a few definitions. First is the autonomic response. So this response system refers to those bodily functions that we don't need to consciously think about to activate. It's our body's natural response system. Things that we think and feel can have a big impact on these systems without our conscious mind being involved in the process at all. So things like strong emotions or outside stimuli will cause our bodies to unconsciously respond to them. So one of these autonomic response systems is called the autonomic nervous system. And the autonomic nervous system is made up of two complementary and opposite response mechanisms. One is called the parasympathetic mechanism, and the other is called the sympathetic response mechanism. And it's this system, this dichotomy of these two different things, that is primarily involved in the stress response and relaxation and calmness. So the sympathetic response, over on the right side, is activated in response to stress. So in the sympathetic response mechanisms, things like the pupils will dilate, allowing more light and heightened attention to detail. The heartbeat is going to increase, right? So you can get more blood to the muscles and you can run away from that lion. The airways will also dilate. You can take in more air, right? You've got to fuel your muscles with oxygen as well. And the sweat glands are activated. Conversely, in the parasympathetic system, when you're at rest or you're calm, the pupils will stay constricted, your heartbeat slows down, you're nice and calm and peaceful. The airways are constricted. You don't take in as much air when you're breathing. And the liver is actually stimulated to secrete bile, promoting digestion. Remember, we said that digestion is something that's shut off when you're having a fight or flight response. You don't have time to digest your breakfast when you're running away from a lion. So if we're continuing down this list, in the sympathetic system, that's activated during stress response, instead of the liver producing bile and causing digestion to occur, the liver will actually increase the rate of glycogen to glucose. What does that mean? It actually is dumping glucose or sugar out into the bloodstream so that you can use this for energy, right? So we said in the last lecture that you need more energy availability so that you can run away from the lion. That's in the form of glucose. We already noted the digestive system is going to decrease activity. You don't have time to digest your breakfast when you're running away from the lion. You've got to use your resources that already exist. And biologically, the adrenal glands get activated. So we haven't talked about these glands yet, but they sit right on top of the kidneys. So you have two kidneys on either side of your body, and on top of them are these little glands that are called adrenal glands, right? And these stimulate the production of two major stress hormones. One of them is adrenaline, which gives you that fight or flight response, and the other is cortisol or glucocorticoids. And we'll talk more about how these lend themselves to creating that fight or flight response with things like changes in heart rate and upregulation of glucose release by the liver and downregulation of these other systems like the digestive system. The uterus will actually cause vaginal contraction under this system. You don't want to mate when you're running away from the lion. You're not thinking about reproduction. The urinary system, however, relaxes, right? So you might wet your pants, right? The bladder is going to relax. If you're running away from the lion, all of that extra water that's in there doing nothing, you get rid of it. It's just dead weight, so you want to get rid of it. Whereas in the parasympathetic system, you'll have blood vessel constriction, right? You've got relaxation in the case of the sympathetic system, and that's going to allow more blood to flow through the system quickly. The digestive system in the parasympathetic side, which is your relaxed and calm state, is going to be stimulated. So you can have your cup of coffee on the back deck and digest your breakfast. The uterus is relaxed and open to reproduction, and the urinary system is increasing urinary output, right? You're having digestion go on, and things are moving through the body as normal. So interestingly, in traditional Chinese medicine, they have this health concept of balance. And this is balance between systems. And this is symbolized by the Taoist symbol of the yin-yang symbol, right? So in the yin-yang symbol, you have opposing forces of yin and yang, which can be anything, really. It could be light and dark. It could be man and woman. It could be represented by many different things. And in medical health terminology, it is balancing the nature of the body so that you maintain harmony or balance between the systems. And so if you're thinking of this way about like the autonomic nervous system, this is actually a good representation of what's going on inside the body. You have these two paired, complementary and opposing systems, right? They complement each other. You can't have one without having the other, and they're going to help each other balance, right? You've got the parasympathetic side and you've got the sympathetic side, and you need both of them in a balanced way to have optimal health. So this is actually very interesting, kind of this traditional Chinese medicine philosophy that looks at balance and harmony inside a system as maintaining a healthy state. So too much or too little of either pathway can lead to disease states, and that's the main takeaway here. So we talked a lot last time about how zebras usually don't get ulcers. This is because they experience stress acutely. The stress arises, they have a response to it, they run away from the lion, and then that stress is over. They don't tend to have chronic stress that can happen to humans, and you saw to baboon populations as well. So in our day and age, we tend to activate the stress response just with thoughts and emotions instead of with actual things that are happening to us in reality. right? And this leads to the chronic activation of these pathways. So chronic stress is linked with many different diseases. It typically doesn't cause the diseases by itself, but it does increase the severity or the ability of these diseases to develop, right? So we're going to see that stress can be a negative impact and be linked to things like heart attack, high cholesterol, stroke, headaches and migraines. It can reduce your immune system response, and you might be more susceptible to colds and flu. It might give you fatigue or low energy, muscle and joint pain, back pain, high blood pressure, muscle loss, accelerated aging, susceptibility to disease and cancer, all of these problems. Oh my goodness, right? So it doesn't typically cause these disease states, but if you have some predisposition to the development of a disease state like coronary heart disease, chronic stress is going to make it worse. So again, it should be noted that this increase in disease state is due to chronic stress. So we should note that acute stress actually can be healthy and it can serve important and protective purposes too. So all stress isn't bad stress, right? We just want to deal with these chronic stressors that we really can't control in our lives and that are causing us to have maladaptation. So we want to reduce those stressors that are brought about by things like runaway minds, feelings, and emotions. And we'll investigate further throughout the term how stress can be involved in the development of some of these different conditions and what we can do to help reduce those stressors so they don't have as big an impact on our health. So you can see again from this graph that the leading causes of death in the United States, the top two outside of COVID for the last few years, is heart disease and cancer. So these are chronic diseases. Chronic lower respiratory disease is up there for women. Men, top three, unintentional injuries. Oh, go watch what you're doing. Don't have so many accidents, right? But traditionally, men have some of the tougher jobs. If you're watching the people that go out on those boats and catch crab, that's a pretty dangerous job, right? You can have a lot of unintentional injuries. So men tend to have more physically demanding, difficult jobs. You might be working on roofs or doing other things that have unintentional injuries associated with them that can lead to death. Then chronic lower respiratory diseases is right up there as well for men. Stroke, the next one for both. Diabetes for men and Alzheimer's disease for women. So women have more predisposition for neurodegenerative diseases. Then unintentional injuries shows up for women. And then diabetes, influenza, pneumonia. You'll see just a little bit different ordering here. And you'll see that suicide also shows up here. So we noted in our health span diagram a week ago, right? We said those top three things that we want to preserve to make our health span improve. We want to improve our cognitive function or maintain that. We don't want to come down with Alzheimer's disease or other neurodegenerative disorders. We want to maintain our physical structure to the body without a lot of pain. We don't want to have cardiovascular disease. We don't want to have cancer, right? And then that third thing was our mood and our mental health. This is so important as we age, and we'll continue to talk about this throughout the term. So for all of these things that cause the four horsemen, right, those chronic diseases that lead to death, stress with just our thoughts and emotions causing this stress can cause chronic activation of the sympathetic pathway, and it can lead to an increased risk for these disease states. So it doesn't cause a disease, but it increases their severity or their ability to develop. you can see that heart attacks, stroke, fatigue, colds, anxiety, depression, and a whole host of disease states are accelerated or exacerbated by chronic stress. So in a previous slide, we briefly talked about the adrenal gland, and it's sitting like a little hat on top of the kidneys. Nice diagram to help you remember this. And it produces the two major hormones that are involved in the stress response. These are adrenaline and cortisol. You may see cortisol lumped together with the glucocorticoids. So that is a class of hormones that includes cortisol. And just so you note it, if you see that, be thinking cortisol. So first we need a definition for a hormone. So a hormone is any compound that's secreted into the bloodstream from one part of the body that has an effect at a distant site or distant location in the body. So this could be the liver. In the case of adrenaline and cortisol, it's going to cause the liver to release glucose into the bloodstream. It also will go and it will affect the lungs, causes dilation in the lungs, right? So that you can breathe in more air. It's going to increase the heart rate, and it's going to increase blood pressure, right? So increase heart rate, increase blood pressure. You're getting blood delivered to more parts of the body faster so that you can run away from that zebra. Oh, not a zebra. So that you can run away from that lion. And then you'll turn down other systems like the digestive system and maybe the immune system if it's chronic stress. So these hormones only get released from the adrenal gland when there's a signal from the brain. So once you assess that there is a stressful event going on, you are going to release a peptide hormone from the brain called ACTH, and that's going to come down and stimulate those adrenal glands to release adrenaline and cortisol. And then a cool feature of hormones is that they can have all of these multiple effects because they cause different responses in different tissues or organ systems. So this is just another diagram showing how hormones work. Again, they're small molecules secreted by one cell. They jump into the bloodstream. They move throughout the body to the target cell. So this may be the adrenal cell that's releasing adrenaline into the bloodstream, and then it's going to bind to the target cell, say in the liver, and it's going to cause that target cell to do something. Right? In the case of the liver, it's going to secrete the glucose back into the bloodstream. So when a hormone can have multiple effects in multiple organ systems, this is called a pleiotropic response. One source causing many effects. And it's one key unique feature of hormones inside the body. They are pleiotropic in their response. So hormone secreting cells are typically controlled by the brain. And two of the regions in the brain that play a major role in this process are the hypothalamus, located here, and then directly under the hypothalamus is the pituitary gland. And the pituitary gland also has a major function in hormone secretion and stimulation. So typically, the hypothalamus tells the pituitary what to do, and the pituitary will release the first hormone into the bloodstream, and this tells the adrenals, for example, to release those stress hormones. So it leads from the hypothalamus down to the pituitary, and you can see in this diagram of the pituitary that it's highly vascularized. You can see this vascular network throughout the pituitary, and this lets the cells of the pituitary gland just dump their hormone into the bloodstream, and it can be taken into the body where it's distributed and then causes those reactions. You also see these little kind of like stick-like figures up here. This is a cell body with a big long projection leading down into the pituitary. This is the hypothalamus. And so neural cells in the hypothalamus actually will extend into the pituitary and they are directly next to those pituitary cells, and so they can help guide the process, right? So when the brain stimulates the pituitary cells then will release their hormone. So coming back to Hans Selye that we talked about last week, and another researcher named Walter Cannon, these were the discoverers of these two major stress hormones. Walter Cannon was actually the first to recognize the role of adrenaline, which is also called epinephrine. So you'll see both of these terms. They're both the same thing. That's this hormone here. And he showed this role in the sympathetic nervous system. He was a Harvard research scientist and an MD around the turn of the 20th century. So his landmark findings were published in a 1915 book that was entitled Bodily Changes in Pain, Hunger, Fear, and Rage. So he coined the term fight or flight response. So we have him to thank for the fight or flight, Walter Cannon. So in his fight or flight response metaphor, this is the way that he conceptualized the stress response as preparing the body for that sudden burst of those energy demands. Selye, on the other hand, pioneered the glucocorticoid component of the story, right? He actually discovered cortisol. Since then, the roles of other hormones and neural systems have also been recognized. And collectively, these shifts in secretion and activation form the primary stress response. So both of these hormones are responsible for that fight or flight response reaction to stress. And we're going to see that cortisol in particular has a more negative effect when it comes to chronic stress. And it's the presence of this guy that causes a lot of that maladaptation. So overall, the stress response in the body activates these two hormone pathways. So the first one that was discovered is the one that starts in the hypothalamus, right, that we just talked about. And this is known as the HPA axis. So it goes from the hypothalamus to the pituitary gland to the adrenal gland. So this is known as the HPA axis. Hypothalamus, pituitary, down to the adrenal gland that's sitting on top of the kidney, and it's going to cause the release of the glucocorticoids. Right? So this is the primary pathway for cortisol. The SAM axis is primarily responsible for the stimulation and release of adrenaline. And this one is just a little bit different. It goes from the brainstem and it goes through the spinal cord instead of going through the hypothalamus and the pituitary gland. And neurons from the spinal cord are going to stretch all the way out to the adrenal gland. And there are different tissues inside the adrenal gland, the medulla and the cortex. The cortex is the one that will release the glucocorticoids like cortisol. And the medulla part of the adrenal gland is the one that releases the adrenaline. Right? So you've got the SAM axis and the HPA axis. SAM stands for the sympathetic nervous system activation, right? This is the fight or flight response. And so it goes sympathetic, adrenal, right? The adrenal gland, SA, and medullary, the medulla component of the adrenal gland. So SAM axis. So notably, the upregulation of both of these hormones can happen independently from one another, right? So if you have a stressor, an acute stressor, the lion jumps out and you got to run away, both of these pathways get activated simultaneously and you're dumping glucocorticoids and adrenaline into the bloodstream. The adrenaline acts a little bit faster, right? It's going to hit the heart and the lungs straight away and make you breathe faster and make you have higher blood pressure almost instantaneously, and you're going to be running away from the lion. The glucocorticoids act a little bit slower, but they're going to cause release of energy from the liver and things like that, and will help you sustain that response so that you can get away. So notably, it's this HPA axis that gets activated in more chronic stress situations where things like emotions and worry and things like that are causing you chronic stress. And these are the most problematic in causing inappropriate activation and disease states to arise, like ulcers and things like that. So just for a closer look, right, this is your kidney, this is the adrenal gland, and if we cut this like this way and we looked at the inside here, we can see that the layer of the cortex is on the outside and the medulla is actually on the inside here. And so these area here is in the SAM axis, and these cells would be activated to release the adrenaline or epinephrine. And then the HPA axis is going to get activated to release the cortisol and other glucocorticoids from the cortex cells. So other glucocorticoids such as aldosterone are also released from the cortex, and aldosterone will help regulate salt and water balance inside the body. Whereas the cortisol is affecting more the blood vessels, vasodilation, vasoconstriction, and also targeting other organs like the liver. So what we learned today is that there are autonomic responses in the body that happen without us thinking about them. And one of these is the autonomic nervous system, right? And there's two components to that system: the sympathetic nervous system, which causes the fight or flight stress response, and then the balancing side to that is the parasympathetic nervous system, which is our calm and peacefulness side of the pathway, right? And so we're going to see that we can do specific types of exercise or activities like mindfulness activities like meditation that will help us engage the parasympathetic nervous system and turn that on. And that's going to be a good thing when we're thinking about health span, because we can help downregulate and create more balance with the sympathetic nervous system. So if you have chronic stress and you're activating cortisol all the time, one way to combat that is to enhance activation of the parasympathetic nervous system. So further, we also learned a little bit more about the sympathetic nervous system, which is also divided into two axes. When you're activating the sympathetic nervous system or the fight or flight response, you have the HPA axis, which goes hypothalamus, pituitary, adrenal gland. This causes the release of glucocorticoids, specifically cortisol, in our flight and fight response. The SAM axis is going to go from the brain down the spinal column to the adrenal gland, and it will hit the medulla part of the adrenal gland and activate the release of catecholamines, which in this case is the adrenaline or epinephrine. So that is called a catecholamine from its chemical structure. We also learned what the sympathetic nervous system does to the body. So that was our diagram about increased blood pressure, turn down digestion, turn down immune system. Parasympathetic nervous system, the direct opposite, right? You're going to relax, decrease blood pressure, increase digestion, reproduction, all of those things, right? So you can see if you have chronic activation of the sympathetic nervous system, that's going to affect things like reproduction, digestion, how well you can digest food, all of these different systems inside the body, your immune system, how well you can fight off diseases, right? And fight off infections. And these are going to be important players to maintaining your overall health. All right, so that's where we're going to end this lecture.